This presentation is related to the 6th module of Principles of Database Design, and the topic is Transaction Processing Concepts. In this presentation, we are concentrating on the term transactions and the desirable properties of transaction, which we'll call it as an asset properties. Transaction. The transaction is one of the most important words that we are using in our day-to-day life. When hearing the word transaction, the one thing comes in our mind is the online transaction. Online transaction means we are transferring an amount from one account to the another. That is, we are accessing one of the account, debit an amount from that account and credit that amount to another account. These much of actions are performed behind the screen, and this set of actions we called it as a transaction. Otherwise, we can say that it is a sequence of operations whose execution transform a database from one consistent state to another consistent state. Or we can say that it is an action or series of actions that are being performed by a single user or application program which reads or updates the contents of the database. Technically, we can define the transaction as it is a logical unit of database processing that includes one or more access operations. Here the access operations means it can be insertion, deletion, modification or retrieval. Insertion means we are inserting something into the database. Deleting means we are deleting some from the database. Modification means we are doing some updations, and retrieval means we are just getting or reading the element from the database. About the transaction boundaries, there are two boundaries are there, begin and end boundaries. So each and every individual transactions can be identified by these boundaries, that is the begin and end boundaries. These end boundaries having two states are there, the commit state and the abort state. So we can simply say that the commit means it is the permanently save all the changes which have made in the current transactions. That means the transaction is successful. We can save all the changes permanently to the database. Next one is about the abort state. The abort means to disturb the action by killing the current ongoing transactions. Generally, a term rollback is used which refers to reverting to a previous stable state in the case of transaction. Otherwise, we can say that the transaction does not complete and none of its actions are reflected in the database. So, we can say that there are two characteristic operations of transactions are read operations and the write operations, or read transaction and the write transaction. Read transaction means we are reading a data item X from the database. For example, the SQL select statement. Write transaction means we are making some modifications to the database. That means we are inserting some element, we are deleting an element, or we are updating the values of an element. And all the elements that the transaction read, we called it as a read set. And all the data item that the transaction T writes, we called it as a write set. A simple example of transaction is, suppose a bank employee transfer ₹1000 from X account to Y account. This simple transactions involves a series of operations or a series of actions. The first action is read balance of X account using readX operation. Second action is read balance of Y's account using readY operation. Then subtract ₹1000 from X account, add this ₹1000 to Y account, write the new value of X back to the disk and write new value of Y back to the, that is, consider the X account having the initial value 5000 and the Y's account having the initial value as 2000. So we are crediting the 1000 rupees to the Y account. Here first you have to access the X account and debit the rupees 1000 from the X account. That is X minus 1000. Now the balance is X equal to 4000. After this, you have to credit that amount 1000 to the Y account. Now the balance of Y is 3000. This 4000 and this 3000, the final values of the X and Y accounts must be written back to the disk. And this is the simple example of a transaction. That is, in the terms of database, we can say that T1 is the transaction 1, T2 is the transaction 2. First, this transaction T1 reading the data item X. Then it's debiting the amount N from the X. Then write this value back into the disk. Then the transaction T2 again read the item X, adding an amount N to the value of X and write that X back into the disk. So we can say that the database consisting of two operations, the read operations and the write operation. This is the step for reading an item from the database. So in order to read an item from the database, first you have to find the address of the disk block that contains item X. That means this is the disk and this is the main memory. All the read and write operations are executing within the main memory. Here in the disk, we are storing the database. So in order to read an item X from the database, first you have to find the address of the disk block that contains the X. Here X means A. So first you have to find the address of this one. That is address of the A within the disk. Then you have to copy this. You have to copy this block into the main memory. Okay. Then copy the item X from the buffer to the program variable named X. Here the program variable is A. Is given as A. Here the program variable is A. So you have to copy this 5000 into the program variable A and read this item from the main memory. This is how the read operation works. In the same way, next one is the write operation. In order to understand how the write operations works, consider the figure. Here in the figure, the disk consisting of the database. Within the disk, we are storing the database, and within the memory, we are doing the write and read operations. So in order to perform the write operations, first you have to find the address of the disk block that contains the X. Here it is A. Then copy the disk block into the main memory if that disk block is not already in the main memory. Then copy the value from the program variable and place it into the correct position within the buffer. That is, here you have to store the program variable with a and the value 7000 into the correct locations within the buffer. Then update the value from 5000 to 7000. Then return back this updated value into the buffer. This is how the write operation works. The next one is the need of transactions. Till now, we discussed about what you mean by transactions, what are the different operations that we are applied or we are using in the transactions, read and write operations, how they are working. But why we need all these transactions? What is the relevance of studying the transactions? We know that a database is a shared resources accessed by many users concurrently. That is, at a time, many users can access database because it is a shared one. If these users are not managed properly, some issues will arise. The two problems or two issues are the problem due to concurrent, that is concurrency problem due to failures. Failures means there may be system failure, software failure, transaction failure. The failures might be happen. So in order to overcome these issues, we are adding or we are using some features of the transactions. The features are or the properties are in order to avoid these issues. The first one is atomicity, second is consistency, third is the isolation, and the fourth one is the durability, or we call it as an acid property. So acid property is mainly used to avoid these issues, that is a concurrency issue and the failure issues. So as in A for atomicity, C for consistency, isolation and durability. So the atomicity means the entire transactions take place at once or doesn't happen at all. That means if a transaction happens, it must happen entire or completely or not happen at all. That we call it as an atomicity. Consistency means the database must be consistent before and after the transactions. That is, the database state must be consistent before the transaction as well as after the transactions. Otherwise, there will be incorrect data will store in the database. Next is the isolation. Isolation means multiple transactions occur independently without interface. Last one is the durability. Durability means the change of a successful transaction occur even if the system failures occur. That means if the system failures occur, the data must not be lost. All the successful data must be stored in the database. That we call it as a durability. At all time we can able to or we can available all the saved data from the database. That we call it as a durability. So this we called it as an acid property, atomicity, consistency, isolation and durability. That's all about the property. So in these presentations, we discuss about the definition of the transaction, that we call it as a logical unit of database processing that includes or that changes the database. And why we need the transactions means to recover or to remove the concurrency problem and failure problem. And there are two operations we studied, the read operations and the write operations. And the property we called it as an acid property, that is atomicity, consistency, isolation and durability. Thank you.